Hi everyone, welcome to the session. In our yesterday's session, we have seen what is business intelligence, what is data warehouse, and what is data lake, how this IICS is transferring the data from this heterogeneous sources to the data lake. So that's what we have seen. I hope you are clear. And this is the front-end applications. So from these front-end applications, we are getting the data through APIs, and we are loading all the data into a transactional database. At the end of the day, we are during the intraday, we need to transfer the data from this particular source system, this online transactional processing, to this OLAP system for the reporting purpose. So different reporting, different processing. The main difference between a data warehouse and data lake is data warehouse mostly used for structured data. Okay, mostly used for structured data. So what is structured data? So data in the rows and columns, the table format, right? So it will be used for structured data warehouse. So if you take Oracle, Teradata, Netezza, so all these databases use structured data only, right? So you have the structured data here. Yes. And also this data warehouse, so it will do the ETL process. So we will extract the data, so transfer the data and load the data into data warehouse. But this data lake, right? So it will handle structured, semi-structured, and unstructured data. Okay, sorry, semi-structured and unstructured data. Unstructured data. So what is structured data? So if the data are available in the tables format, so that is a structured data. If the tables, the data are available like a logs, okay, logs, cookies, and if you take all the streaming data, mostly like unstructured data. So if you take all the online, so if you take all the social media content, so most of them are unstructured data. Okay, semi-structured data means structured and semi-structured. If you take email is the best example for semi-structured data. So the to address, CC address, BCC, and everything is like a structured one, and subject and body of the content, attachment, everything is like unstructured one. So data lake can handle structured, semi-structured, and unstructured data, and also it will be used for ELT process. So what is ELT process? Most like we will extract the data from the source, live streaming, we'll be extracting the data, loading the data. After loading the data, we will be processing it. So that's what we will have ELT process. Okay. Extraction, transformation, and then, extraction, loading, and then processing. So most of the machine learning algorithms, artificial intelligence algorithm are happening in the data lake environment in that ELT process only. So this is what the data warehousing. And if you take for business intelligence, as I have mentioned in yesterday's session, business intelligence is nothing but so taking the good decisions by effectively managing the data. So the business users, they will be taking the decisions by looking at this particular statistics. They will be generating different kind of metrics from all the data. Okay, collecting the data to data warehouse. And it has 4 stages. We have the first aggregating the data, then presenting the data, then the business people analyze the data, they will take a decision accordingly. Okay. Say for an example, manufacturing company, car manufacturing company, they are manufacturing the cars from different units, different manufacturing units with different variants, different colors, different attributes. And they want to check, so in this particular location, which variant is moving fast, which location this particular variant is not moving. Okay, stocks and everything, they will transport and they will do see the transport cost and lot of analysis they will do. Okay, so from transporting from A position and then selling in B position, if it is taking more transportation cost, they will think, okay, so instead of having this particular manufacturing plant here, we will put nearest to this particular place there so that we can avoid the transportation cost, right? So this is one of the analysis I'm saying. A lot of analysis are there. So based on the customer supply and demand, they will do lot of analysis. See, this kind of analysis, if I want to do, I have to collect the information from various source systems, right? So we have to collect the data across the globe. We have to take it. So that's what we are going for, the business intelligence. And if you take the warehousing architecture, as I have already explained, so here we do have the source layer. If you take source layer, enterprise resource planning, CRM data, and payroll information, okay, SAP, so all the databases and so other data sources, we can take the data from here, flat files and everything. So it has been mentioned with the two different types of data load here, batch load. So that's what the ETL load, we are saying that it will be scheduled, right? It will be scheduled on the different frequency of data load, and then it will be pulling the data from source and we are loading into the data warehouse. That's what we are doing it. Real-time data is like it's streaming the data. Okay, so continuously we are getting the data, right? For an example, satellites, we are getting continuous data. So that is real-time data. And all the social media. So all these are real-time data. Continuously, it is getting generated, data is getting generated, and it will be like a streaming the data from the source, and we are loading into a data lake. After that, we are processing the data. So for various machine learning and artificial algorithms, and also for merchant reporting also. If it is business data, yes, we will go for a lot of business analytics we will do. So here we do have the data integration layer. If you see this is the data quality purpose. So we will do the data profiling. It's nothing but we are summarizing the data for a lot of quality analysis. We are doing it. Data transformation we can do, and data cleansing, data validation, data auditing, data quality. These comes under the data quality. So many of the project, we will have the data quality system. So you might have heard about this IDQ, right? So IDQ we might be using, and then we are doing that data quality and data profiling. So this is the something like a QA stage. Some system, some project, we will call it as it's a QA stage. In this particular QA stage, we'll be doing that data load, like all the data profiling and everything. We are doing it by the quality team, and this might be the source for our ETL team. So this is the source for our team, and we are fetching the data from this QA stage and loading into our stage or ETL stage. Staging environment is nothing but loading the data into our data warehouse or data lake. It's mostly like 100% truncate and load. Truncate and load means it's like up to yesterday's data or the frequency of the previous frequency of data load has been loaded here. We will truncate and then load it. Why? Because all the incremental load, we will do it on the EDW, Enterprise Data Warehouse. Okay. This concept I will explain later in the project explanation. So that I will tell you. Some of you already worked on Informatica PowerCenter. The same concept is applicable here also. Then the data is moving to the data mart. So as I told, different data marts we have. So based on this data mart, we are sending the data customers. Okay, the business analytics and merchant reporting, different kind of. This is the data warehousing architecture. Okay. And if you take this is functional architecture of our data warehouse. If you take this is the data source system, you can see the source systems are CRM, customer relationship management, inventory, payroll information. Payroll information, mostly like our companies will use payroll in SAP, right? Yes, sales, general ledger, and production data. All these data are there in the source system, and we are collecting the data to the data warehouse. So from the warehouse, it will be taking for a different kind of reporting. Okay, like customer profitability, supplier performance, productivity. These are all different metrics. So it depends on the domain. If it is a banking domain or based on the domain, we are taking the data for a different kind of reporting. So that's what business analytics team, they will do. All these analytics are from Tableau or Power BI or ClickView, ClickSense. So these kind of data visualization tools, we are creating this kind of reporting. Okay. And even for merchant customer reporting, so we will do. So this is what the data warehouse architecture is mainly used. So if somebody asks what is data warehouse, this is the definition given by the Inman. So Inman is the father of data warehousing, right? So he only suggested very first time, okay, instead of having the OLTP system, we can have OLAP to load all the data, historical data. And in OLAP, we can do all the analysis. So that's what the data warehouse. So data warehouse is nothing but it's a subject oriented, organized with major subjects like customer, supplier, products, merchant, sales. Okay, different subject and integrated. All the data are integrated from heterogeneous sources and it's a time variant. Time variant means historical perspective, we will take the data. So we will never ever overwrite or delete the data in the data warehouse. Historically, we will load. So that's what the data warehouse will always have the history. If I want to do any kind of data forecasting, data mining, okay, if I want to do, so all this forecasting will be done in this particular data lake and data warehouse only. So why? Because so how much the data science project, if you go with the data science or anybody else, machine learning and all the data science algorithms, right? So they will feed for the supervised learning or unsupervised learning, whatever the learning method you are using it, they will feed huge volume of data. So how much volume you are feeding you are going to give for the learning system. So that much level of accuracy you can expect. Okay. So that's what they will go for the data warehousing data for previous years, and then they will do forecasting. So even the forecasting is available in Power BI and Tableau. If you feed more data for last 4 years and 5 years, if you give the data, so it will predict next year accurately. So what could be the statistics? What could be the the future statistics? It will decide based on the previous data. So they will do all the forecasting by analyzing the previous data. So for that, they will use huge volume of data, mostly from data warehousing. If you see this, we are taking non-volatile collection of data to support management decision-making process. So that's what we'll go for. I got one question. What about truncate? Truncate, you said if you can delete any data in data warehouse. Normally, we will not delete the data in data warehousing. Okay. We will never ever delete the data in data warehousing. Okay. So you ask about the staging layer, right? The staging layer only we will delete. So why we are deleting it here? We have already loaded the data into core layer. Okay. The final tables we have already loaded, but we need to land the data from different source system. Okay. Say for an example, you have data, different source system. We have to land these data into the data warehouse first. So why? Because if the data warehouse is there in Teradata or Netisa or any other cloud system, first we have to land the data into this particular database or data lake. After that, do the transformation logic. Why? Because that's what the performance wise it will be good. So just we are landing the data in the staging layer, we will truncate and load. Okay, this is one layer of data warehousing. We will truncate and load here. After that, we will incrementally load the data into data warehouse. Okay, so that's what I have explained here, right? We do have multiple layers here. Staging only, we will do the truncate and load. After that, we are doing all the data load. So here the core layer we should have. So here all the data are incremental data load. Okay, so I hope you are clear. If not, yeah, so wait for some time. I will explain this concept in the project level. So we will never ever overwrite the data in the core layers, okay, the final tables. If the data are already exist, we will check for the update. Okay, we'll check for the update. If update is available, yes, then we will update the data. So we will make the existing data as inactive. Then we will add one more line, one more record. We will make it like active. Okay, and the previous data is mainly used for the history purpose. Okay, so what is you joined a company with a different designation, different years of experience. After that, the designation is changing, your experience is changing, your skill set is changing. So all the kind of previous history, whatever the history they want to collect it, they will collect your address and everything. So that's what they will keep it for history. So they do have different kind of strategy they will be using. Mostly like SCD type 2, they will use for the history maintenance for in the dimension table. Collection of data to support management decision making process. Okay. And why do we need data warehousing? Okay, in the real time system, as I told, the operational system. So what is operational system? Operational system is nothing but OLTP, right? Sorry, mouse is not correctly working. This is OLTP. The operational systems are OLTP are being impacted because of reporting request. If the company needs any reporting, if they are taking reporting from OLTP, this will get impacted, right? The transaction, it will get impacted. That's why we are going for the OLAP. So that's the reason we do have a data warehousing or data lake. So we have to take all the reports from this particular data lake only. Operational system, that means your transactional database cannot give a needed historical perspective data. So we cannot have a 40 years, 50 years of data in one particular database, right? If you're keeping all the 50 years, 40 years of data here, then the transaction also would get impacted. Your analytics also will get impacted. That's why we are keeping two different systems. Here we are using this particular one for only for the transactional database. Okay. The business is not getting consistent or timely answers. See here, if you are keeping non-transformed data here, then always for reporting, you have to transfer it. So every time, okay, single currency, if you are collecting from data from various countries, if you take one bank, uh, the bank is having multiple countries, presence in multiple countries. They do have different currencies, different policies, and different regulations, right? But they want to know that their profit and what is the transaction happen, they will look at all this transaction in one single currency finally, right? So every time I cannot go and change it, transfer it. So one particular time we will transfer it and then this will be used. So that is what we are using for data warehousing and data one single view. Okay, so one single view of business is this data warehouse. So every time if you're transferring, right, it is very costly, too expensive, and it is too difficult to manage all the systems. Okay, so that's what we are having a data warehousing environment. So these two members are fathers of data warehousing. So first, he is the father of data warehousing, Inman. So very first time he only suggested that instead of having OLTP, we can have it. So in the year of 1980s, so 1980s itself, okay, 40 years before, he has mentioned, okay, he has published a paper in the journal that instead of having transactional database, we can have separate database for the data maintenance. So his approach is called it as top-down approach. So what is top-down approach? For an example, if you have the database here, transactional database, you move the data to the data warehouse here. Okay, data warehouse here. First you create the data warehouse, you load the data. After that, you create the data mart. Okay, so after that, you create the data mart. So his approach, we will call it as top-down approach. After creating, okay, yeah, very good. Then after creating the data warehouse, if you are creating the data mart, that is called top-down approach. Okay, top-down approach. So first we are creating the data warehouse first, and then we are loading into data warehouse. Sorry, data mart. We are splitting the data for subject wise, and this approach is called it as top-down approach. After 10 years, Ralph Kimball has suggested that this is taking a lot of time. So first to create the data warehouse, it is taking a lot of time. It is going for the, sorry, my mouse is not working correctly, but creating the data warehouse is taking a lot of time. Instead, first we will take the data to data mart. Okay, since we need the data immediately for this simple unit, we will take the data here to the data mart. Okay, if you want the data from the single unit, yes, you take data from here. After that, you load it here into the data mart. Okay, sorry, data warehouse. This approach, we will call it as bottom-up approach. It's based on the particular system, a particular project. They might be using top-down approach. They might be using bottom-up approach. It depends on the project team architecture. These things will be handled by the data modeling team. Data modeling, they will take it. So what kind of approaches they want to go for. So they might be using the Erwin tool and different kind of tools they might be using for the data modeling and everything. So why? Because this is very less time consuming. So you can take the data from here. After that, you can take even some project, they will go for galaxy approach. So what is the galaxy approach? Sorry, hybrid approach. So hybrid approach means they combine so this one and this one, and like after that they will create a data mart here. Okay, so like this they will combine it. It is called hybrid approach. Okay, so which approach they are using? Okay, you have to check with your project team only. So project team only, data modeling team, you have to check how they are using. So after you can, if you are working in the project, you can go and check. After loading into the data warehouse table, then you are loading into data mart. Then this is top-down approach. You are doing it. Okay, so you have to check. So how the data load is happening. You can check it. Okay, by yourself. So what is the dependency? How the data is getting loaded? Dependent tables. You can check it. So whether the data mart tables are loading first, then data warehouse, or data warehouse tables are loaded first, then data mart. Okay, that you have to check it in the project only. We have to open the dependent flows and you have to check. Okay, or you can ask your senior members, architect, somebody else will be there, right? You can ask them. Data modeling team definitely will have, so you can ask them. If you see this bill in one model, so it's a top-down approach from the source system, the heterogeneous sources. We will do the ETL process, load the data into data warehouse, and from the warehouse again we will do the ETL. It's like a lot of ETL process will be happening inside. It is not a single layer. We will take the data from source to data warehouse. Many layers. Okay, it will be flowing. The data will be flowing with the dependent tables, and then finally we are loading into core tables, data warehouse tables. Like you might be seeing that dimension table, fact tables, and lot of tables will be there in the final tables. Okay, that's what the core tables you'll be seeing. Is it mandated to build the data mart? Yes, they will do. So if you go to the real-time project, definitely you can see the data mart. Okay, whenever you are seeing that _DM or any schema, if you are mentioning that _DM or DM_ any schema, if you are referring, so those are all data mart tables. Okay, they see data warehouse and data mart, they're in the same database only. Same data warehouse. Data warehouse also, it's a database only, but it can handle huge volume of data. That's it. Okay, everything is like in the single database only, but logical division. Whenever you are seeing the schema name with the DM_ or _dim anything, sorry, _DM or DM_, all the schemas are used for data mart. Okay, data mart. So these tables are data mart. You'll be working. Okay, so one particular data mart you'll be working. So you can heard about this term. Okay, data mart. That's what you can identify whether we are loading into a data warehouse tables or data mart tables. It is mandatory to have this data mart for the easy and secure the secured manner of getting the data from the data warehouse. Okay, so I'm working for one particular data mart. I will have only this access to this data mart. I will not have access to any other data mart. Okay, that's what we will split up on the security wise. Bottom up approach is nothing but first we will load the data to data mart here. Okay, we can, if you want to take the data, yes, you can take it from here. So single unit. So unit by unit, you can take it, and then you can load the data to data warehouse. So from here also you can create a data mart here. This is hybrid approach. Okay, this is hybrid approach. If you are taking the data, so if you see this, data marts are first created. The creation of data warehouse itself, they will create the data mart first, then they will combine all the data mart, and then later they will build a data warehouse. Okay, so that's what the bottom up approach. You can see here the difference between bottom up approach and top down approach. So it is to give you the more extra knowledge. So you can see this and you can learn. Okay, so sometimes if you are going for any client round or anybody those who are having knowledge on data warehouse, right? So they will be asking this type of questions. Okay, have you worked on data warehouse? What is data warehouse, data mart, all these questions? So that time you can answer these questions. Okay, building a data warehouse, the top-down approach is time consuming. First, you have to build a complete data warehouse, then we have to build data mart. But Kimball model, it takes lesser timing. Okay, so first you create the data mart, then go for the data warehouse. The maintenance here, it is very easy. Okay, so time consuming in the first time. After that, maintenance is very easy, and subsequent cost is initial cost and subsequent cost is very less. But here maintenance is difficult since we have lot of data mart in the beginning, and then we have different revisions in the subject areas. Then we have to create every subject areas data mart. Then we have to do it, right. So this will be taken care by data modeling team. Separate teams will be there. So they will be taking, but as a developer, we have to load the data into these tables. So this will take longer startup time. After that, it is taking lesser startup time. This is for a specialist team. Okay, skill requirement is specialist team, generalist team. Anyone can do that. So individual business areas we will do for the Kimball model, and enterprise wide we will go for the Inman model. So this is the difference between two models. And we do have hybrid models. See, this is the hybrid approach. Okay, so why? Because do the source system, first data mart. So if you take so this one is bottom up approach, and then this one is top down approach, right? So if you combine both, then this will become a hybrid approach. Some project, they will use hybrid approaches also. Okay. So what is dimension and fact tables? So in the real-time project, definitely you'll be using these two tables, right? In the data warehouse, you'll be seeing these two tables only. So this is nothing but a dimension fact tables. So what is dimension table and fact table? Say for an example, you have one company. So at the end of the day, you want to know so how the business is going on. So you have customer base in different countries. Within the country, you have customer base in different locations, different cities, and all this, right? And then different products and different. So if you take a grocery selling app company, or you do have, and they do have customers, then they do have different products, different delivery partners, right? So like different kind of dimensions, the attributes of data you'll be using. So those tables, say for an example, customer table is the one dimension table. All the customer details, we will load it here. Whenever if the customer is changing the data, we will use SCD type 2. We will make the history here. Yes, it's a customer data. Then products, all your product will be there in the product table. Location, city, country, all these tables, right? Country table, location table, time table. So these tables are called it as dimension table. It will have a primary key and attributes. And attributes means different dimensions. So if you take, you are an employee for a particular company, the employee ID is the primary key. Okay, we are the employee for a particular company, right? Employee ID is the primary key, and your attributes, your name, first name, last name, your mobile number, your date of birth, your email ID, your address, your skill set, your designation, everything is like attributes. They will maintain it on table. If anything, you are going to change it here, they will make a history. Okay, previous one. So that's what they will do it in the data warehousing environment. Then client information. Yes. So your your employee information, your client information, your the different project information. So all these details are different dimension table. They will maintain it. When it is going for the billing, say for an example, I want to take invoice. Okay, invoice I want to go for. Okay, this particular employee worked for this particular project, this particular customer. Okay, so if in this particular location, this particular country, this particular date. Okay, all this. So one day, uh, this is what the billing, right? 1 hour billing, 1 day billing, 8 hours. Then what is the total billing? So this billing informations, all these are fact tables, the transactions, right? The fact tables. So every day we'll be getting the data. So centralized fact tables, and it is surrounded by multiple dimension table. Okay, this is the dimensional modeling we will follow to take the reporting. Okay, I want to know. So in India, how many employees are there? So what is the invoice? Okay, the total amount. Okay, in India, how many clients we do have, and what is the total amount? So a lot of analysis we might be doing it, right? Different geographical area we want to do the analysis. All this the company will do. And I will go for, okay, this particular quarter, how many headcount we have added, what are the different skill set we have added. So a lot of technical, if you go and check any companies, the quarter the results is the example for the reporting, right? So if I want to take this kind of reporting, how the companies need to collect the data, right? So all the data we are collecting in the dimension modeling with the different dimension table, and it is connected with the fact tables. So this is the source for our Tableau team or the Power BI team. Okay, this entire model. So this model, we are going to load the data as a ETL developer. Okay, so that's the fact tables are surrounded by multiple dimension table. Okay, sometimes what will happen, one dimension table, you may have a repeated data. You may have that redundant data. So instead of having denormalized table, okay, so having the duplicate data, what we will do, we will go for normalization process. Okay, normalization process. That means from one dimension table, we are doing the normalization process and we are creating another dimension table here, okay, to avoid the data redundancy. So this is outer dimension, this is inner dimension. This dimension table will have the primary key, and this dimension table will have that foreign key. So this particular key will be a foreign key in this particular table, right? It's in the dimension table. So this model, we will call it as snowflake schema. Okay, snowflake schema. What is that model? Snowflake schema. If you do not have this particular table, this is called a star schema. Okay, snowflake schema means in the star schema dimension table, if I want to do a normalization process, that will become a snowflake schema. Okay, so even we do have the galaxy schema, multiple dimension table, multiple fact tables are connected with each other. Okay, so this is what we will go for the one. So what is denormalization process? If you ask what is denormalization process, we will load all the data like aggregated data here, right? So like summarization of the data here. So the summarization is nothing but denormalization. Okay, like we have this particular quarter, this is the sales, and all this summarization we are doing it, right? For the reporting purpose, that is called denormalized one. But we'll go for normalization here. So why? Because I want to go for even in depth. I want to reduce the data redundancy here. Then I will go for the one more level of granularity. Then that's it. This particular one is called snowflake schema. I will tell you. See, always remember fact table, right? Fact table will have a foreign key. Okay, FF. You assume that fact table will have a foreign key. So this dimension table will have a primary key, right? So these primary keys are kept in the fact table. So fact table is always having a foreign keys and measures. Only measures it will have. All the keys from the dimension tables, and it will have the measures here. Okay, clear? So whichever the table is having primary key, so that table we will call it as dimension table. It will have only attributes. It will not have any measures. If a dimension table has any foreign keys, that means it is there in the snowflake schema. Okay. So if you take this particular example, I will tell you. So in detail, I will explain. So what is this particular dimensional modeling? Why? Because this one you should able to understand first. So then only we'll go for the you can able to understand in real time project how we will do. See here in the source system. So in the source system, we might be using different data modeling. Then we are collecting all the customers' data. So every customer is loading their details, right? It will be captured here. But in the data warehousing, we will go for this dimension and fact table load only. So if you take here, is there any layer like a semantic layer? Yes, semantic layer means one by one I will come to that. Okay. Semantic layer and all I will take in the project explanation. But since you have asked, I will explain. See, yesterday we have seen this is stage layer, then work layer, then this is core layer. Finally, we have some, not only these three layers, we do have different layers. I have explained here, staging layer, it's a truncate and load, right? Then work layer, we will do all the transformation logic here. Core layer, it's a final load, we will load. all the final tables will be available here. Tables. Normally for the reporting team, we will not assign the tables. Okay, what we will do, we will create one more layer here, So that layer, we will call it as, so this particular layer, we will call it as semantic layer. That means semantic layer will have only views. Okay, views from the base table. So based on the customer's request, we will create a views here. Okay, views here. This views is called it as all the tables, right? So from the views, we can collect the data. These layers we will call it the semantic layer. Clear? Okay, now I'll come to the dimension table. If you take dimension table, okay, you have a business. You assume that you have a business. You have some electronic shop. So in the electronic shop, you have business in multinational companies. You have some India, all over the India, uh, you have the shops and you are selling the product. Okay, you have the manufacturing unit, and then you are all this you are doing it. So all this I have to analyze it. So what will you do? First of all, so each manufacturing unit, each product, customer details, store details, the shop details, location details, transportation details. See all this in delivery details, all this information you will collect, right? So you want to have these details for the reporting purpose. Okay. So I want to analyze my business from different dimensions. So location wise, right? Store wise, product wise, customer wise, employee wise. These kind of analysis, if I want to do, I want to have the data in the different tables. To avoid the data redundancy, we will load it here, right? So these tables will have a primary key. So product table, yes, you will have a product ID, product description, all this. And the customer table will have the customer ID and customer informations. Store details, locations, the employee details, account details, all these are user details. All these are dimension table. So dim underscore, D underscore, or underscore dim, everything is like a dimension table. Then we do have the fact tables. Fact tables are, all these keys are having here. Okay, so you are doing one transactions. So how you will take the transactions normally in this particular date, this particular product purchased by this particular customer, this particular employee help, and in this particular store you have purchased this particular regions. This is the quantity you have purchased, unit price and total price. So this way we will load it data in the data warehouse, and we will go for, okay, at the end of the day, I want to know for today's date. So what is the total price? I will do group by or where equal to where date equal to system date. It will be located this particular system date. And this is what the total price, right? So I will make sum of all the total price. I will get this particular total price. And how many units sold? See, all this kind of analysis, I will do it on the data the environments. Pradeep, please give me some time. Okay, so I'm explaining that model, right? If the fact table only I'm explaining. Okay, if you're not giving that, can you please explain? Means I'm explaining that only. It will get interrupted. Okay, so that's why I'm telling. So if it is, I'm explaining the fact table only. Okay, so this is the fact tables, and you have the this particular date, this particular product, all this you will be collecting. This is the transactional tables. A lot of transactions, all the transactional tables, right? The tables are called it as fact tables. Sales table, transaction table, invoice fact, purchase item fact, right? Orders table. So all these are fact tables. So fact tables will have all the foreign keys and measures, right? So I cannot load all this dimensional data into one single table, right? Can I load all the dimensional these data into one single table? Then all this data, no, this fact table will become very bulky, and I cannot track the history also, right? I cannot track the history also. If you are changing your mobile number, I cannot go and load it in the transactional tables, right? So I will load it whenever you are doing you are changing your customer mobile number or address, anything. I will do it on the customer table only. I'm not going to do your attributes on the fact tables. Fact table will have only transactional data for the business analytics. So if you join these tables, then you can take the reporting, right? So this kind of reporting, we will call it as, this is the schema, star schema. Star schema is nothing but A centralized fact table is connected with multiple dimension table. See, this dimension table will have a primary key, right? This is the primary key, and this will be a foreign key here. So all the foreign keys. Okay, this particular customer in this particular country, in this particular city, this particular employee, okay, sold this particular product. This is the unit price, quantity. So these three are called it as measures, right? Measures. And these four are foreign keys. It's coming from the dimension table. Okay, so which table we have to load first? In data warehousing environment, if you are going to do a DTL load, so always you are creating a workflow for Informatica or IICS load. So which table we have to load first? We have to load dimension table first, right? Always you have to load the dimension table first, right? So here we will be loading the dimension table first. So it will have the primary key, and then only you have to load the foreign key. If you are loading the foreign keys, it doesn't have any product information. For an example, today, new product has been launched. So that has been entered into the source system. Okay, they have launched a new product. Business has launched a new product. So that product information should be loaded into the first product table in the dimension table. Then the transaction, we have to load it. Got it? If you are not loading the first dimension table, you will be getting the integrity constraint violation, right? So, no, there is no parent key found. So that kind of error you'll be getting it. It will fail. The fact table, it will fail. Integrity constraint violation, parent key not found. This kind of load issues you'll be having. Sometimes the dimension table might not load it correctly. So that time you are trying to do the fact table load for the particular date, you'll be getting this particular dependency data load, right? So you'll be getting integrity constraint violation error. So you have to check what is the dependent table for this. Yes, for this particular data load, this key is available. This key is coming from here. Say for an example, the key number 123 is coming. You are trying to load here, but 123 is not available here. So you have to check which table is loading this particular, which is a dependent table for this particular product table. So whether this table load has been completed for the day or not, so you have to refresh, right? So always you have to check the data load. You have to refresh this particular ETL load, and then you have to go for this particular fact table. So that's what you can avoid this kind of dependence issues. Okay, this is star schema, and snowflake schema means, see, this is the snowflake schema. Customer table, locations table, sales item, products table, time table, right? These tables are the star schema. But customer information, again, I'm having a lot of duplicate here. To avoid the data redundancy, we are splitting the table into one more table, normalization. Normalization process, we know, right? First normal, second normal, third normal we will do. Normally, we will go for third normal process. In that particular time, the customer type, okay, we will put it here, what type of customer he is. Whenever I needed customer type, with this type ID, I will refer to one more dimension table. I will get this particular type description. It is not only 2 columns, we will have more columns here in this particular table. Okay, whenever needed additional level of granularity data in the reports, then I will refer this table to get the data. But always we will split the tables to avoid the data redundancy. So what is this data? In this architecture, which table we have to load first in the snowflake schema? So these two tables you can load, the outer tables, right? Sorry, this will be one. First stage you can load. If there is no dependency between these two tables, then first stage parallel load you can do it, these two tables. After loading these two tables, the second stage you have to load all the inner dimension load table. Once all the dimension table loaded for the particular day, you have to load this particular fact table. Okay, this is what the ETL developer we will do. Okay. Yes. So I got one more question. Is there? Okay. Yeah, I hope I answered. Yes. See here, this is what the snowflake schema. If you ask what is normalization process, see, you have one table called employee table. Okay. Previously, I had employee and their office address, EMP _ office address. You assume that this is one table we had it. So what we had it? Employee informations, their name, mobile number, address, date of birth, email, skill set, and everything. Their office address also we have put it. This is one example I'm saying. Their office address also we have made it here. See, assume that you have 1 lakh employees, 100K employees you have, right? And I have only 5 different offices. Only 5 offices I have. For 1 lakh offices, the 5 offices you are repeating, right? Multiple times. This particular employee, office number 1. This particular employee, office number 3, 4, 1, 2, something like that. You will be repeating only 5 addresses. So you are repeating the 5 information, 5 office addresses multiple times here, right? This is data redundancy. This is one kind of data redundancy. To avoid this, we will split this table into 2 tables. So one is like office addresses. The other one is employee details. The employees are from these particular offices. And here we have only 3 office address, right? Office address 1, 2, 3. Only one time you can note. That's it. Then this particular key, we will define it here. So this is the outer dimension table. And this is the inner dimension table. Okay. You may have, this is a different dimension table also. But if I want to connect here, we will put this kind of relationship, right? So in this data load, we have to first this load. If I do not have 4 here, I cannot load it here 4, right? So can I load, if I do not have any 4th location, can I have employee from the 4th location? No, right? So this data will not get loaded. So you'll get the dependent load, will get the error. So that's what will not do it. So this kind of doing the splitting the tables to avoid the data redundancy is called normalization process. Okay. In the Snowflake schema, we will do the normalization process. Clear? In the Snowflake schema, we will do the normalization process. Galaxy schema, that means multiple dimension tables are connected with multiple fact tables. That's what the Galaxy schema. Okay. So the real-time project, most of the project we do have this particular model. Okay. The Snowflake schema. I will tell you one particular example where we have used the dimension load. I will tell you the real-time example. Just a second. Okay. Sorry, just a second. So can you able to see this particular document? So if you take, this is one of the sample architecture of the dimensional modeling on the data warehousing side. So this inner table is called it as fact table. You can see here F underscore. See, this has been, you can, in the real-time project, it will be created in the VCO, VCO, you know, right? In this F underscore, you can see here F underscore tables are there, some account details or something. Okay, you have that tables. This is fact table, the centralized fact table. Then we do have dimension table. These are all the dimension table. You can see D underscore, D underscore, D underscore, right? These are all the dimension table. So if you open that particular in real-time project in the tool, you can able to see this columns, all the columns. See, this is the real-time number of columns you'll be having it real-time varchar, different data types, all this. See whether this is the star schema or Snowflake schema. So by looking at, you can see this particular architecture is star schema or Snowflake schema. You can identify, right? It is a Snowflake schema. So why it is Snowflake schema? See here, this is the fact, sorry, this is the fact table, right? This is one dimension table. You can see here, this is one dimension table. In this dimension table, we are splitting again 2 different dimension table, right? 2 different dimension table, right? See, these 2 are 2 different dimensions. This is one dimension, this is another dimensions. So this is our in Snowflake schema. So first we have to load these 2 tables as ETL developer. So we have to collect the data from source system, dependent tables, and we have to load these tables first. and then these tables, dependent tables. Okay. Then you have to load the centralized fact table. That's what we will do. See, different teams are involved with different tables. And you can see here one particular system headcount is like only star schema. Okay, this is only star schema. It's a depends on the applications, depends on the project teams. You'll be having a star schema or snowflake schema. Both you will have it. Okay, and then you'll be having a galaxy schema. See, lot of tables are related with each other. See, different source systems, sorry, different ETL teams, they'll be loading different tables. So it's not only one single table, you are loading it, right? So it's different tables, different teams are loading. Based on the dependency, we have to, based on our team, we have to check at the dependent tables and we have to load it. So this is the Galaxy schema. We do have multiple dimension tables are connected with multiple tables. Can we able to do the mapping, Informatica mapping, if we get source table record as an image or audio? No, so that we cannot do it. That is the streaming data. Okay, so that data you can get it as a streaming data. Normally the Spark and the data load, they're doing it, right? They will do it. Normally we are doing it for business analytics. We will get the data in the tables only. You heard about this data type called large object. Sometimes if it is audio file or any other file, you will be having a large object columns. From that large object, you might be getting it. So that is also structured only. We will get it. We will load it in the tables. Okay. So large object column. So go through that LOB, character large object, binary large object columns are there in the real-time project. Yes, binary large object. So those kind of large object data, we will load it. Clear? Yeah, this is what the dimension. I hope you are clear now. What is the dimension table and fact table? Just you can do some kind of homework. Okay, so I request everyone, don't stop it here. Do it whatever I have explained today. So whatever I have explained today up to now. So do some kind of homework here. What is data warehouse, ETL, data lake? What is top-down approach, bottom-up approach? You go and check it. Okay, so in the net, and then do some kind of analysis. Just 5 to 10 minutes. What is dimension table? What is fact table? How it will be loaded? All this. Okay, clear on this? Just to go through that, you will get clear idea about the star schema and snowflake schema and everything. So tomorrow we will go with what is the difference between data lake and data warehouse, and the data modeling also. What is cube and everything I will explain. Okay, we will stop it here. Rest I will take it tomorrow. Okay, so I got one question. Can we take curriculum? Yes, I will send you the curriculum. Okay, yes, I will send it today to you all. Can we talk about types of dimension fact tables? Yes, I will. We will talk. Okay. So just to check it today. Today I will give you one assignment. Types of dimension table, types of fact tables. Just to check it today. We will discuss tomorrow. Okay. The types of dimension table and everything. Galaxy schema means multiple dimension tables connected with multiple fact tables for the data warehousing reporting. Okay, first normal, second normal, third normal. You want all this? Okay, so I will do it. I will explain tomorrow. Yes, please. If you have any other questions, if you need any details, right? I forgot to send. Please always send that questions in the WhatsApp group. I will respond to your questions. Okay. I will add. Okay. So the students, I do have WhatsApp group. I will add it. What is granularity? See, these are all data related one. Granularity means a level of details. Okay, one more level. All these are granularity. So what kind of level you are getting? Okay, country is one granularity. Inside country, you have this cities, right? That is next level of data. Inside city, you have lot of in the state, you have lot of cities, you have lot of stores. So these are all granularity level of details. Okay. In real-time projects, whether we will use Snowflake or Star or Galaxy, as I told, I have explained you, right? All the schema we are using. Okay, any other questions? I will post these questions along with the questions I will send you from tomorrow onward. See, whenever we are going for the hands-on training, right, from next week. So definitely I will send you separate homework sheet. Okay, homework sheet. So open that homework and do it. So today also I will send you some quizzes regarding this particular number. I have personal laptop which I'm using in my office work. Do you do you think there I can use VMware? No, so don't use office laptop for this particular training. Use personal laptop. Okay. If you have in your office, you have dev environment. All this you can practice it, no issues. But so this is very simple. The installation is very simple. I will tell you how to do the installation by next Monday. Okay. First, we will complete the data warehousing, all this concept. The next Monday, we will have this installation. Okay, installation. All this we will do it on Monday. I hope I have answered all your questions. Okay. If you have any questions, if you want to discuss, please raise hand. I will unmute. We have another 5 to 10 minutes. 5 minutes we will discuss. Okay, I hope I have answered in the session itself. I have answered your questions, but still, see, one more thing. It is not all the topics I cannot complete in single day. Day by day, I will explain. Okay, project related stuff. Give me some time. Yes, if you have any questions on these topics, you can ask me now.
Yeah, hi Chandra.
Hmm?
This is Surendra.
Yeah.
So Chandra, when you say we don't delete the data here in the data warehouse, right?
Correct.
So we follow at least the soft delete process, like soft delete method
Yes.
here.
Yes. That's what inactive, right? That is called
Yeah,
soft
flag.
delete.
We assign some flag and
Yes.
we make it
Correct.
inactive.
Correct.
Okay.
That is a soft delete. Soft delete
Okay.
means we will make the existing data as inactive and we will put one more record. So that is the active record we will maintain. Okay. That is a soft delete. Yeah. This concept I will explain in the SCD concept. Okay. Regarding SQL exercise, is there any day to complete? Yeah, you take your own time to complete. Okay. So take day one. You watch my SQL sessions videos in YouTube, and first you practice. Okay. Don't straight away. Don't go for exercises. First watch my sessions, then go for the exercise. Okay. Then only you can able to answer all the questions.
Hi
Yeah,
Chandra,
please go.
yesterday I asked, right, like how to decide like how many data marks we have to keep, like on what basis we'll decide to keep
Data.
data marks.
Yeah. It's depends on the business. Okay. It depends on the business. You will be having all the data marts. If you go to real-time project, right? If you check how many the schemas are there with the data mart, so those many data mart, they will be maintaining it. It depends on the business. Okay. It's for the different kind of business we have, right? Like a domain, okay,
Okay.
banking domain and retail domain, insurance domain. See, these domains only, they are using most of the data warehousing projects. And yeah, it's based on the project, they will use different domains.
Okay, I can say one downstream is called one data mart, right?
No. Downstream is different. Data mart is different. Data mart is final step. Okay.
Okay.
Downstream is nothing but the information we are providing to the consumer, right? They are the downstream. Say, for an example, we might be loading some tables, right? We are the
Yes.
upstream for them. For us, they are the downstream.
Okay.
Okay. In between, you have a lot of downstream, upstream are there in between the data warehouse. They are all the dependent teams.
Okay.
Are we going to
Hi,
have a
Chandra.
common database while going to IICS? Yes, I will tell you. Okay. I will tell you all this on installation. Okay. Database, how to use all this. Can we have view concept in English? Okay. That's all SQL topics. Okay. Yeah, please go ahead. Yesterday I have answered it. So give me some time. I will add it in the YouTube.
Yeah, hi Chandra. I have shared my number. Could you add me to the WhatsApp group?
Yeah, I will do it. Okay. So I will do it. Okay. I have added most of them. Only I think 1 or 2 members I missed out. I will do it. Okay.
And is there any particular order of learning for this course?
Order of order of
Order of
learning.
learning, I mean.
You have to
Yeah.
first learn SQL. And if you do not have much information on the Informatica, so please watch my 10 hours video on Informatica. Okay, so you can see Informatica. 10 hours video, right? 10 hours. If you put this way, you will get this particular 10 hours video. Please go through all the 10 hours video. You can install Informatica PowerCenter. If you are thinking to install Informatica PowerCenter in your machine, go for 11G software. Okay, go for 11G. I have already explained. Don't go for 21C. 21C is not compatible with this PowerCenter. If you are planning to have PowerCenter and IICS both are in the same machine, go for 11G. You follow the installation video I have already posted. Okay, and then start practicing all my SQL session and Informatica sessions. Okay, that is the order.
Okay. Thank you.
See, one more time I will explain. If you have any questions, right, please raise hands. I will unmute. I will give the control. Okay, then only I will get the control. Okay, I got one question. How can we decide how many dimension and fact tables will be there in the? See, that we cannot decide. It's a business. We do have a lot of based on the business metrics and a lot of business metrics. We'll be creating a more dimensional fact tables. Okay. Yeah, I will explain this concept. Tomorrow we'll see the dimensional modeling, like a conceptual model and logical model, cube concept and normalization process. At that time I will install. For IICS, is it must to install PowerCenter? That's what I have explained. If you want to learn PowerCenter, okay, in your personal machine, if you want to install it, it is up to you. You can install PowerCenter. Okay. If you are already working on PowerCenter, you do not want PowerCenter in your machine, directly go with IICS. Clear? It's your decision what to have in your system. So if you need only IICS, yes, it's fine. We can have all this concept in IICS itself. But for IICS, if you have Informatica PowerCenter, that's a added advantage. If you have antivirus software, definitely Informatica PowerCenter will antivirus software will remove that particular exe files. So please remove that, disable it. IICS no need to disable. What is the difference between static and dynamic schema? No, I do not have any idea static and dynamic. I'm not sure what is static and dynamic schema. Okay, so who are all not there in the WhatsApp group, or who are all not there, you are not getting the recording, please ping me right away. I will add it in the group. Okay, so who are all not there in the WhatsApp group, please ping me now. I will add it right away. Should we have 21C in, see, multiple? That's what I'm telling, right? See, you are listening the class or not? How many times I can explain the same concept? If you want to have IICS only, okay, if you want to have IICS only, go for Oracle 21C. Are you clear? If you want to have IICS, Informatica PowerCenter, both you want to have in your machine, go for Oracle 11G. Is it complex explanation I have given? This is the answer I'm telling. Okay, if you want only IICS in your machine, go for Oracle 21C. If you want IICS Informatica PowerCenter, you go for Oracle 11G. Okay, so why? Because I have explained this yesterday itself and today itself, but I'm getting the question same. Please make a note of it. Any other questions? Are we good? Okay, so we will stop it here. If you have any other questions, please make a note of it. I will send you some data warehousing quizzes. Check that quiz and try to answer it. Okay. Thank you all. We will meet tomorrow, same time, in the same link. Thank you all.